Good day, everybody. And for this short lecture, we're going to understand about various uh, aspects about data that Visual Basic handles. So, for this session, we'll talk about the various data types, and then we'll talk about how to declare variables, and at the same time, how to declare constants. From these words, we understand that a variable is something that keeps on changing from time to time. And we did talk about this in class that at times we may try to reserve some memory location that will, from time to time, change its value. And that is uh, called as a variable. And one that doesn't change is called as a constant. For example, constants can be used for calculations in long programs. For example, we know a constant like pi 3.14. We can have that one so that whenever inside the program where you have this constant used as pi, automatically the program will pick up the value of pi that you've really passed across, and it will execute the program. So this is actually what happens. So constants and variables are very important in programming. Now, to move quickly, we are trying to talk about us or people dealing with lots of data in day-to-day life. For example, we encounter names, phone numbers, and then we have addresses, and then money, date, stock quotes, statistics, and etc. All these are types of data, and they are not all processed the same because they are not of the same type. And that's why we need to tell the program that this is what you're going to handle. Why is that important? Because the computer needs to store enough memory for some of that data, and at the same time, it needs to know how to process that data. For example, if you're working with integers, then the computer will know it can add the values. If you're working with date, it can know how to add the dates or project the dates. If you're working with currency, it knows this is money. And all these types of data have got their memory allocations reserved. So that is very important. Now, just but to move faster, in Visual Basic 2017, data can be stored in variables, constants, or arrays. So we can store information as a variable or as a constant. And we are trying to say that variables change and constants are going to remain the same throughout. Now, data types. Now, one of the most important one is this numeric, but then we say here that in VB 2017, information can be of two main data types, and the first one is numeric data types and non-numeric. So this means that a numeric, the data that is going to be of numeric type or numerals, meaning that we can be able to add or compute the information. But non-numeric, now you just start the information and maybe there's a way you can manipulate it. So that is what we have. Now, quite faster, we are saying here that this numeric data types comprises of numbers. That's very important, and which are divided into basic based seven types based on the type of values that they can store, and that is very important. And we have this one just right here. These are the numeric data types. We can have what we call as a byte, we can have integer here, we can have long, double, single, and then we have currency here. What I want you to notice this. So for us to store a byte, the storage size is a byte here. Integer is what? 2 bytes, and then long is 4 bytes, single 4 bytes. These two more or less they have the same length, but then down below we see there's more space coming in here, and you can see the ranges all on this other side. So then that means that each type of information has got a unique characteristic, and in this case it is storage size and the range. So that means that the double is much more space is required as compared to long and single. And then we have currency here, it's 8 bytes, and then decimal here is more or less one of the biggest chunks that we can have in terms of storage. So we have 12 bytes here. So we have types of numeric data. So you can have either a long or a single or an integer. So we are going to look at how this is. And on the other hand, we have non-numeric data. Now, this non-numeric, they comprise of string. Now, string, in most cases, people say that they are either letters, alphabets, which are in double quotes, and maybe they make meaning because things like names or name of places, nouns, verbs or something like that. Those can be called a string, and you cannot compute this name, for example, unlike numbers which can be computed. So we have also the date type here, and then we have the boolean. The boolean, it's a true or false, something close to that. So we have here, so we have string. These are non-numeric data types. So meaning our computer can handle non-numeric. We need to tell it that this is non-numeric, and then it will know what's going to happen. So string, we have storage is the length of the string. Yeah, now that's okay, and we have this range, 1 to 64, 5,400 characters. So that's so many characters. And then we have also this for fixed length string, but for variable length, we have length of plus 10 bytes. So storage can be much larger, and then the range can go from 0 to 2 billion. Then date, we have it from January 100 to December 31st. This number is a very large number, but not very large. Then we need 8 bytes for that. And then we have boolean 2 bytes because only 2 false, 1 or 0, something close to that. So that's what we can do that. And then we have others here. One is called object variant, and variant, we have a variant for numeric and for text, and any value as large as double or some same as variable length. Now this we may not be able to use this in this class, but then we might get it as we progress more advanced concepts. Right here we have what we call as a suffixes for literals. Now literals are values that you can assign to data. Now that is very important. Now we can assign lots of value to variables, to constants, but now we have something here that we call as suffixes. Now in some cases we need to add a suffix behind a literal so that VB can handle the calculation more accurately. Now we need to tell VB that now this is the type of data type that we have by adding this, so when it does its computations, it's more accurately. Now we have these suffixes. You see a prefix comes before something, a number or something, and a suffix comes after something. So I'm sorry about this. I've been quite unwell for some time and my voice is just back, and I want to ensure that I don't strain again. So we have the suffixes, meaning that after a number. So like here we have this number plus this, so we know that this is a double. So the program will, of course, execute this more accurately. Unlike when you just leave it like that, it might be long, single, or double. So it's good for us to tell the program to do something more accurately and to know what is happening there. So if you have currency, we can put this. If you have long and this other one, so these are what we call as suffixes for literals. Okay, yes, so there they are. So variable and constants, we did talk about this, that a variable is a name that is given to, let me call it a space for us to know what we're going to store there. Now this variable name has got rules, more especially when it's being formed. For example, we say here that it must be less than 255 characters. Don't have very long variable name because it's going to be a problem for you even to remember, even when you're programming. Short, precise, to the point is very important. So less than 255 characters. No space allowed. So if you're giving a variable name, don't say variable or say div Ben marque as a string. No. And then this Ben marque are 2 words. No. You have to make it 1 word. So there's no space allowed within a variable. And then it must not begin with a number, and period is not permitted a full stop. So that's why we have these words as the correct ones, and these ones are not right. Why? There's a period here, a number is starting here, and we have this special characters and everything which are not permitted, etc. So let's be very careful when we are declaring variables. This is the syntax for declaring a variable. So the keyword is dim. Once the program gets this keyword dim, it knows what is following is a variable, and then we need to state this variable. What are we going to store in it? This space that we're reserving, what are we going to store in it? Is it numeric? Is it non-numeric? Is it, if it's numeric, is it integer, long, decimal? If it's non-numeric, is it string or something else, boolean, something like that? We need to know that. That's why we say that we need to have dim variable name as data type. So we say dim benmark as string. That's just an example I'm giving. So we can declare them in, if you have so many variables, let's say you have a very long program, so you can have them declared one variable after another, or you can separate them by commas, as we have seen here. You can have so many variables declared in a straight line, and then just separated by a comma. That is what happens. So we will declare it using dim. So this is how it can be done. You can see they are all being declared one after another, or we can also use this method over here as also a possible way of declaring variables. They all work. They all work. Right here we are seeing that this is form load, and then we have declared this. It's like now when the program is loading and the form is loading, these instructions are executed. I will try to do something about that. And then we have here just an example of how a message can be declared using a message box. So this is for a button that we are saying that a variable name is your message. This variable is going to be a string. So what happens is that this happy birthday is a string because it's inside double quotes, and these are alphabets, something that is being stored there. So this information inside this double quotes, the string, is going to be stored in this variable which is known as your message. So what happens right here is that in a message that is going to be thrown open up, we are going to have the message that was in this variable. Maybe to quickly just show us how this is, let me just double click here on the form, though that's not where it is, and then we say dim your name as a string, and then you can say your name, good, is equal to, and then you can say hello to you, second year students of Visual Basic, something close to that. And then after that, we can now say this message box is going to display what we have there. So I think this more or less what we have just right here. So your message. So if we now, let me be very clear here. If I run this program, then it means that it is going to show me the message box as soon as the form loads. So that's the first thing maybe I'm supposed to see, because I've not put any button there or anything. So I hope there's no mistake here, and maybe let me try to run it. Now if I run it this way, all right, here we have hello to you second year students of Visual Basic. That's what we already have, because this is what we have here. So I can just click on OK here. Then we have our form there. The form has loaded. Now it was this this code was written on the form load event now right here, but now I can decide to remove that one there. I come here and then I put a button. Now this button, I can double click now the button. Now you can see button here, click, and now I can paste this information right inside that button. So then that means if I run this program, I've not changed the name of the button or doing anything like that, but then I know we all understand how to do that. If I click, notice the program, and now I click on the button here, we have this message coming right here. So that is how we can just go around that. I was just trying to illustrate how we can use this uh, keyword dim to declare a variable. Now I want to move fast because my voice will not be sustained for a very long time. Now we have what we call a fixed length string. For example, you want either your name to appear only 10 characters or 15 characters only. You can declare it this way. So this means that for the fixed length string, you must use the syntax as shown below. So if we go back to our program, we can do more or less that. We can say market or your name, and then that's either 5 or 10. And then from there, I think we are supposed to see only that showing up in our in our program. But then let's first just move quickly to the next concept right here. Sorry about that. Yes, so that is it. So how do we assign? Now a variable name is here and an expression is here. So that's how we did, and then we utilize this assignment operator equal sign. So we know that assignment is done from this side to this side. That is how it's done, and that's why in our software here, not code here, we have this is the expression. This hello blah 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 is the expression. It's being assigned to this variable because the variable name is here. Your name, that is the variable name. So that's how it works. So quite fast. That's how assignment is done, and that is how it has been done there. So there is incompatible data type. If you pass in any incompatible data type, we're going to throw up some error. If you declare that you're going to store string and then you pass decimals or numbers or something like that, I don't know, maybe something is going to happen, and that's not going to be good. Now, the scope of declaration, let me just go to this code here. The scope, we can understand it this way in simple terms. Anything inside here, it is local, meaning it's local to the button. So when the program is executing the code in this button, when it comes to this subroutine or this procedure, then that is the end of it. So that means it is local. But then at the same time, we can decide to have it as a public thing. You can declare something here. Radius so integer, something close to that. Circumference, integer as well. Okay. Now I'm just trying to explain something here, that we have these things declared here. It's something like a global way of declaring, and you can be able to access these declarations when you use them somewhere inside this. But now in our notes, we know that we have been given these keywords to use. Private, we know private, it's local. We have static, one that does not change. It will help us all throughout the program. It's just written here. The static keyword declares a variable that's going to be used multiple times, even after a procedure has been terminated. After a procedure, it's still there, you can get it. Then public, you can use it anywhere. So we are going to use public in some of the programs, statics, and private. So that is something that is going to happen. So the final thing is constants don't change. Pi is a good example. If you have a button there and then you put this code there, you're going to have it shown that the constant is always there. Now remember, this is pi and then times, and this is for showing that we're going to square this r twice. So that's what we have for that. So that's how we're going to work with data. Otherwise, thank you. Let's see the other examples in the next lesson.